see which one we looked at, but let's move on to 14, and then you can choose the next one. 14 on page 185. We are still talking about radical equations. And here it is. The square root of x plus 10 equals x minus 2. What type of equation is this? Of course, it's a radical equation. It has a radical in it. Good. What do we need to do? First, we have to keep in mind that the radical has to be isolated on one side, alone by itself, if you want, on one side. And it is. We don't have to move terms around. So then what? We have to square both sides. But remember, we square both sides as one unit. Is 5 the same thing with 2 plus 3? But if you make the error to do this, that would be incorrect, because this is 25 and this is 4 and this is 9, and they're not the same. So when we square, we have to square the left-hand side and the right-hand side as one unit. Okay, the left-hand side, can anyone give us the left-hand side? Good. Can anyone give us the right-hand side? I needed. Yes, we're past that 3 weeks ago. Yes? Awesome. Indeed. Very good. Very good. Thank you for making the effort. Even if you just make it for me, I'm happy. Good. So what type of equation is this now?
Quadratic.
Thank you very much. So this is x squared minus 5x minus 6 equals 0, which means that we have to move everything to one side, of course. So I subtracted x and I subtracted 10. Perfect. Now what? Can anyone give us which method you would like to apply, and what is the next step? We have 4 methods. So yes, if it takes more than, I don't know, 15, 20 seconds to factor, forget it. Use the quadratic formula. Unless you are specifically told you must use blah, blah, blah. Otherwise, you do what you want. So, ready? Anyone? X minus 6 indeed, and x plus 1. Perfect. So then x equals and x equals. Very good. But remember, I cannot put enough question marks and big enough. What does that mean? We must go back to the original problem and check. Perfect. So the square root of x plus 10 equals x minus 2. This is the original problem. That's where I go and check 6. So when you check 6, does it work?
Yeah.
Excellent. Good. Now I want to check negative 1. Of course, negative 1 on both sides.
No.
Negative 1, correct. Negative 1 plus 10 is 9. The square root of 9 is 3, but this side is negative 3. Obviously, we'll say no. This is called, there is no need for you to memorize this if it's difficult. I'm not going to test you on this. This solution is called extraneous solution. It's a byproduct of squaring both sides. And of course, it does not work in the original problem. Okay, do we get the idea of radical equations? Do you think we need more examples?
Yes.
Okay, would you like to choose, or do you want me to choose? I choose. Very good. Okay, so I'll choose 18 on the same page. X minus the square root of x plus 11 equals 1. Now, our first question is this. Of course, what type of equation is it? And you will say, no, you cannot say rational.
Radical.
You have to say radical. Good. Second question is, how many radicals we see here? 1. It has to be isolated, alone on one side. I see a negative in front, so I would rather do this. and write, yes, x minus 1 equals the square root of x plus 11. Is it wrong to move x to the other side instead and have negative the square root? No, it's the same thing. I just don't like having too many negatives, and especially starting with a negative. But it doesn't matter. The solution will be the same. The answer will be the same. What do we do next? Excellent. We square both sides. And now the right-hand side. Very good. Now the left-hand side. The formula is the first term squared minus 2 times the first times the second plus the second term squared. What type of equation is it?
Quadratic.
Very good. We move everything to one side. X squared minus 3x minus 10 equals 0. X goes to the other side. 11 goes to the other side. Any questions? Any questions? Okay. Say it again. Sure, but you don't need me to, right? You can do it on your own. This is quadratic, so you really don't need me to show you any of the next steps. So it's factorable. Anyone?
Excellent.
Very good. So we get two options. Very good, but they come with a big question mark because we squared both sides. So since we squared both sides, we have to go back and check back to the original problem. I'm checking 5. Please tell me if it works. Yes, it does. Let's check negative 2 now. Stop me if you have questions, please. No, because we have 9. The square root of 9 is 3. With minus in front is negative 3. 2 minus 3 is not positive 1. So I will say just 5. So I think we should work on these equations as soon as possible tonight, tomorrow, right? And bring more to class and say, I tried it. It comes from my math lab. I didn't get the answer. Show me. And we'll do it in class. But I think we have enough unless you really need another.
This is section 1.5.
This is section 1.6, other types of equations. Section 1.6. Ready to continue? Okay, the next in line is equations with rational exponents. If we're told we're given x to 2/3, what does this mean? What does x to 2/3 represent? The cube root of x squared. So the general formula is x raised to n divided by m. The denominator is m. Then this is the mth root. The index is always the denominator, and the power is always the numerator. So every time we see an exponent that is a fraction or ratio or fraction, we know that this is a radical. So maybe we should write this down in words. Fractional or rational, the same thing. Rational exponent means a radical, or it represents a radical, whichever is easier for you to remember. So because the denominator is always the index, this will be the cube root of x to the second power. So the numerator is the power, the denominator is always the index. Can anyone tell us what x to 1/2 represents? Very good, the square root of x. Can anyone tell us what x to 1/3 represent? represents. Exactly. So please remember this concept is very important. So we are going to deal with equations that have expressions like this one, because the exponent is a rational with rational exponents. Equations that have terms that have rational exponents, or the variable has rational exponents, in other words. Okay, so let's start with a simple one like 32 on page 185, in which we are given x to 3/2 equals 27. Now, the obvious question is this. You could say, wait a minute, if an expression with a rational exponent means a radical, why can't you just call it a radical equation and solve it like this? What's the big deal here? Right? If I said that any rational exponent is nothing else but a radical, why do I have to call it differently instead of simply writing radical equations? Well, it's because sometimes squaring both sides or cubing both sides is more difficult, and we may have to use a different method. So it's good to have this completely separate, although it's a radical equation at the core. So you could change this into the square root of x cubed equals 27 and take it from there. It's fine. Instead, however, I would like to show you a different method. Slightly different method. It's basically the same. So every time we have a fractional exponent, we would prefer eliminating the denominator first. Well, not in one step. You could say, okay, let's take both sides to 2/3 and we're done. Well, there is a problem with in some situations if you want to eliminate the power in one step. So we will not use this. So I'm going to copy the problem. So it's x to 3/2 equals 27. First, I would like to eliminate the denominator. What should I do to both sides when I want to eliminate the denominator first? I should. Of course, yes, of course. Okay, I squared both sides. Remember, if I square both sides, I will have to do what at the very end? Check. Very good. Very good. Okay, so then copy the base, and remember the process is to multiply the exponents. 3/2 times 2/1 is 3. That's why we multiplied. We took both sides to the third power. So then we have x to the third equals 27 squared. So what is, can anyone give me 27 squared? I get 729.
Yep.
Okay, now how do we proceed? At this step, I want to eliminate this. What should I do to both sides to eliminate this piece? To cube root. Very good. Indeed, the cube root. The cube root does not have plus or minus. Remember, we looked at equations with taking square roots, not cube roots, right? Square roots. And we had to put plus or minus in front. This does not happen for an odd index. Okay? So, okay, how much is the cube root of 729? Let me show you two different ways of determining the cube root with a graphing calculator. So let's do that for a second. You may know, you may not. In math, there is the cube root. I never use it. There is also any index root right here. Right? So this would be the cube root. I prefer, so you can just choose 4. And you know me already, I have to have parentheses everywhere, especially under square root, cube root. There is no operation here, so it's really not required at this point. Okay? So this is one way. What I normally do, I never go and click on math. I just put 729 power. Can anyone give us the power? What power is the cube root? It cannot be the third. So we cannot say that 2 cubed is the same thing with the cube root of 2. What is the power when we talk about the cube root? Exactly. In parentheses, 1 divided by 3, close the parenthesis, and you get the same thing, of course. So these are the two possibilities for cube root or any other index. So I prefer just writing this, 729 raised to power 1/3, but you have to put it in parentheses. This is my preference. You choose what you want. So the answer is 9. However, it does come with a question mark because we squared both sides. So you can plug it in. This is what I would like to do. I want to show you that option as well. So we have 9 raised to 3/2. But 9 is the same thing with 3 squared. We're going to use this a lot. 9 is a prime number, which is 3 raised to the second power. Everything raised to the 3/2. Copy the base, multiply the exponents, and you get 3. And that's how we got the 27 on the other side. So I highly recommend whenever you have or you're given an equation with fractional exponents, always eliminate the denominator first and then eliminate the numerator. Let's look at one more. Unless you have questions. Any questions? Let me stop and ask you. Any questions here? Any questions?
How do you get 9?
You mean this one?
Yeah.
We showed it in the calculator. We put it in the calculator. The cube root of 729. Is that okay? Good. Okay, so 34, x plus 5 raised to 3/2 equals 8. So what should we do first? Where is the starting point? First, we should ask ourselves, what type of equation is it? And yes, it is a radical equation, but it's that special type of radical equation called with rational exponents, basically. Okay, so then what will you do first?
Square it out.
Yes, indeed. We want to square both sides. And we get on the left-hand side x plus 5 to the... Very good. And on the other side, 64. Okay, what next? I'm afraid I have to put my tent up very soon for the sun. Okay, so what do we get? What do we do?
Cube it.
Very good. The cube root. In order to eliminate power 3, we apply the cube root, which is power. Which power is the cube root? 1/3. Excellent. Thank you. Very good. So the left-hand side is x plus 5. And remember, there is no plus or minus. And we know that the cube root of 64 is 4. We move 5. This is what type of equation? Linear. Very good. So x equals -1. It comes with a question mark. I have to go back to the original problem. This is the original problem. X plus 5 to 3/2 equals 8. So if I replace x by -1, -1 plus 5 is 4. And I'm checking 4 to 3/2. Of course, I'm going to change 4 into 2 to what power?
Square.
Good. And then multiply the powers and get to cubed, which is indeed 8. Yes, you can also do this with a graphing calculator. I was hoping you wouldn't, but it's okay. Do you think we need another example? Yes? One more? Perfect. What about 38? On the same page. Everything is on the same page. X plus 5 to 2/3 equals 4. What should we do first? We are not squaring both sides. We have to eliminate the denominator first. And in order to eliminate the denominator first, we have to cube both sides. Good. So then the left-hand side is x plus 5 to the... Excellent. And 4 to the 3rd, we are... Yes, we just looked at it, 64. Okay, what now?
Square.
Exactly. We know this a method from quadratic equations, right? How many solutions do we have to get? 2 indeed. So let's take the square root. And then we get x plus 5. That's why I asked how many solutions. I can't accept 8.
Plus or minus.
Right. That's why I asked before we apply the square root. So we don't forget. So then x equals -5 plus or minus 8, and we have to separate them. If you had made the error of taking both sides to 3/2, you would have gotten only one answer. There is a formula I caution you in the book. If you feel comfortable with it, I never present this. I think it's redundant. I don't think it's useful at all. As long as you remember to eliminate the denominator first and then the numerator, you really don't need this. But if you'd like to, please look at it. It's on page 179. I think it's just doing this instead of this. But that's just a personal opinion. Okay, moving on. Our next type of problem is equations, or type of equation is equations quadratic in form. What is that? Well, I'm just saying the core is quadratic, but the equation is not quadratic. So quadratic in form at the core, but they're not quadratic. We're going to use a method called substitution. We will substitute. Okay, so if you want to choose, please feel free. If not, I will. I'd like to start with 42. X to the 4th minus 13 x squared plus 36 equals 0. Okay. Notice one thing. I'm going to ask you what type of equation is it? And if we hadn't discussed this, what would you have said? Polynomial, correct. Polynomial. What is its degree?
4.
How many solutions? Exactly. So it's also a polynomial, degree 4, 4 solutions, which implies 4 solutions. So it fits 2 different categories. However, there is a formula, but we don't use it. There is a formula for the 4th degree polynomial, but we don't. It's too much. So I noticed one thing, that this is x squared and this is x to the 4th. So if I say let y be x squared, so if I want to denote this by y, what could this be denoted by?
Y squared.
Yes, this piece is y squared. Why is this possible? Because this equation at the core is indeed quadratic. It's not quadratic. It's polynomial degree 4. But at the bottom of its heart, it's quadratic. So now the new equation becomes t squared minus 13t plus 36 equals 0. The question is, why would I do this? Because this polynomial degree 2 is easier to factor.
T or Y?
Oh, I meant y. Sorry about that. Thank you.
Okay, actually have
Thank you.
grilled.
I'm sorry. I don't want to confuse anyone. No, it's y. So this I know how to factor. It's in descending order. It's a trinomial. Greatest common factor? No. Negative leading coefficient?
No.
No. Special product?
Oh, yes.
Yes. Special product. Can anyone give us the special product? Why?
Plus
It cannot be plus. This one is minus, right?
1 minus 6.
Everything squared. What is the middle term of this?
6x.
What is the middle term when we expand this into 3 terms? What is the middle term?
6.
Very good. Negative 2 of y. So it's not a perfect square. This doesn't work. Okay. Is the leading coefficient 1?
Yes.
Good. So then we can factor it right away, if it's factorable. Is it? Good. How do I factor it?
Y minus 9
Excellent.
and y minus 4.
Excellent. So then we do get two solutions in y. You could say, who cares about your y? We do. And you'll see in a moment why we care. So y is or? Exactly. Now this becomes a new equation. Can anyone give us the new equation?
Y squared minus y plus 1.
X squared equals 9. We're just replacing back y with x squared. We don't do anything else. Y is the same with x squared. Can anyone give us a second equation? Do we all agree with this step? Any questions here?
Wait, how did you get y is the second x squared?
Y equals x squared. I have to remove it from here and replace it by x squared. I have to go back to the variable that I was given. In the same way, this equation is x squared equals 4. Do we all agree? Good. So now which method do you apply here? We have 4. Of course, taking the square root. Do not say square. You have to say taking the square root, right? Is that clear? We understand the difference between taking square roots and squaring?
Yeah.
Awesome. So how many solutions? And I should have, we did write a little note. So please give me the answer here.
Equals plus or minus 3.
Very good. Plus or minus 3. And the solution for this one?
Plus or minus 2.
Very good. Oops, I didn't mean to write it again. Plus or minus 2. Okay, did we get 4 solutions here or not?
Yeah.
Perfect. Any questions about equations that are not quadratic, but they are quadratic at the core, quadratic in form? I would like to look at least one more if you agree. Any questions? So what did we do? We used a substitution to make our life easier. That's all we did. Can I use it all the time? No. No, it's not going to work. For example, if I have x cubed minus 2x plus 1 equals 0, even if I call this t, this is not t squared. So the method does not work for this polynomial. This polynomial at the core is not quadratic. So it's nice when this method is applicable, but it doesn't work in all situations, as you see. Any questions on the method before we look at another problem? Are you with me, everyone? Yes? Okay. I think I'm on page 5. Okay. I'd like to look at 56. This is x plus 3 squared plus 7x plus 3 minus 18 equals 0. No one can see. I'm sorry. Okay, so I'm going to ask you what type of equation is it? It's also quadratic, right? If I square x plus 3, I get x squared. There is no higher degree than x squared here, right? So it is quadratic, but it can also be treated as quadratic in form and quadratic in form as well, as long as I can find a substitution to make the equation easier to solve. Otherwise, forget it. I will expand and distribute, but that will be, I think, more work. You can say, not for me. I still would like to show the method of substitution here. So let's say t equals any letter but x, of course, any letter but x. So what will you say? Let t be what?
Yeah, let t be x up to square.
Very good. This is our t. As long as this is, and if it isn't, I cannot use the method. As long as this is, yes. Is it t squared? If this is denoted by t, is this t squared?
Yeah.
Of course, when we square x plus 3, we get x plus 3 squared. So we denoted by t this time. It was obvious, I thought, but maybe not clear, very clear for everyone, that that's the quantity that we are going to substitute. So can anyone dictate the new equation, which is much easier than the previous one, I would say?
Uh,
Very good. This I know how to factor.
oh. X plus 9.
Yes?
Well, t minus.
Excellent. So it appears that we have two solutions.
T equals 2 and t
Negative 9 and 2. Very good. Awesome. But now this is a new equation, and this is a new equation. Can anyone give us the new equations?
x plus 3 equals 2.
Excellent. Exactly. X plus 3 equals 2, and x plus 3 equals negative 9. Indeed. Great job. So now I want the final answer, and we're done with this, I think. Indeed. Indeed. Awesome. We didn't square. We don't have to go back and check unless you want to. And this is what we call equations that are quadratic in form. At the core, they are quadratic. If you encounter other types of problems under quadratic in form, please bring them to class on Wednesday, please. Okay, moving on. We have one more type, which is absolute value. Absolute value equations. I looked at your progress in my math lab. 4 of you are still not registered, and I'm not sure why. Except one student who explained the situation, but 3 I haven't heard from. So you're not registered, you're way behind, 2 weeks behind already. 3 students are way ahead of time, way ahead of everyone, and I thank you for that. You're doing an exceptional job. So I'd like everyone to move at the same pace, please. Okay, let's talk about absolute value equations first with a very simple example, and then we're going to choose problems from the book. This is one of the simplest possible absolute value equations. Remember, this is the distance from 0. The absolute value of x, distance from 0. So we are asked to find numbers whose distance from 0 is 2 units. What will you say? Excellent. That's all. So now we can choose anything you like from 61 through 76 on page 186. And then I would like to apply any of this, anything, in a word problem, so we understand why we do this.
Let's do 65.
Let's do 65. We picked 65, and that is 2x minus 1 in absolute value equals 5. Remember, on the previous situation, I asked you, what does this say? It says, find x such that the distance from 0 is 2 units. This time I'm asked the same thing. Find x such that the distance between this number and 0 is 5 units. So what can this number be? Can I put here Can I put here 4? No, because the absolute value of 4 is not 5. Can I put here 0? No. But what can I put in here? Or, that's it. That's how we look at it. Nothing else. So 2x minus 5 has to be 5. 2x minus 1 has to be 5 or negative 5. The exact same process. Nothing different. It's just that now I have to solve an equation, which I didn't have to solve before. So I'm moving 1, so 2x equals 6, so x equals 3. I'm moving 1, 2x equals negative 4, x equals negative 2. Same idea. Everything is the same, right? It's just that now you take that expression and set it equal to, right? Of course, a situation like this, what do you think? What will you say about this equation? What type of number is this always?
Positive.
Correct. So can you ever find an x that makes this positive and at the same time equal negative 3? No. So what do you conclude about this equation? It has,
No solution.
excellent, no solutions. And one more example, and then we'll pick others from the book. What if I have this situation now? Which number has the distance from 0 units? 0. So this one has only one option. It's 2x minus 1 equals 0, or 2x equals 1, or x equals 1/2.
I said only has one solution.
Just one solution, yes. Yes. I thought you said no solutions. Yes, just one. This one has only one. There are other equations, but I don't see them here, so I'm not going to bore you with that have infinitely many solutions. But that's good enough for what we have. So let's look at 72. Same page, 186. So 4, absolute value of 1 minus 3/4 x. Absolute value plus 7 equals 10. Yes, this is still what type of equation?
That's absolute.
Right, but it's not cleaned up. It's not fully simplified. It needs work. So now, I'm going to answer before you ask. You cannot touch the absolute value. You cannot move anything outside. You cannot put anything inside. You cannot distribute anything. You cannot touch anything.
Can you subtract 7 and then divide by 4?
Yes, that's what I said. Yeah, we have to do that. We have to clean it up. Yes, but we cannot distribute in here. We cannot take anything out. This is untouchable. But yes, in order to clean it up, of course, that's what we need to do. We will be moving 7 and we divide by 4. So the absolute value of 1 minus 3/4 x, 10 minus 7 is 3, 3 divided by 4. And now it's completely cleaned up. We are ready to. So remember one other thing. Every time you see an absolute value, except in this situation, you will have to write 2 options. You are always asked to write 2 options. Yes, please.
Wait, how did you get rid of the 4?
It's multiplied. Is that okay, everyone? Any questions?
Multiply by
I'm sorry?
multiply 2 what?
To eliminate 4,
Yeah, how did you
I divide by 4, both sides. Because it's multiplied, I have to use the multiplicative inverse. 1/4. If it were 3, I would have divided by 3. Is that okay, everyone? Yes? Okay, so can anyone give us the 2 options, please?
Would it be 3/4 x minus 1 equals 2/4?
1 minus 3/4 x equals
3/4.
awesome.
And then 1 minus 3/4 x equals
That's it. Thank you. Bless you. That's absolutely it. These are the 2 options. Nothing different from before. Nothing different. So now let's solve each equation. I move 1 to the other side. So negative 3/4 x equals 3/4 minus 1. I'm missing a quarter. Or x equals 1/3. Do you need me to show any of intermediate steps or anything? Is this clear? Yes.
Can you? Can you show how you got 1/3?
Yes, please.
From here,
Mm-hmm.
or from here. Is it clear that subtracting 1, you have 75 cents, but you owe me? I just wanted to review this for everyone. So you have 35 cents, but you owe me $1, so you still owe me a quarter, correct? So far so good. 3/4 minus 1 is negative 3/4. Okay, both sides have the same denominator, so you multiply both sides by 4 or negative 4, and you get 3x equals 1. So you divide by 3 to get 1/3.
Oh, okay.
What?
I see what you're saying.
Say it again.
I'm still confused.
So first of all, it's a negative of both sides. So you multiply both sides by negative 4. Negative 3/4 times negative 4 is 3x. Negative 1/4 times negative 4 is 1. And you divide both sides by 3 to get 1/3.
Oh.
This is a linear equation. You shouldn't even look at what I'm doing. Just do it in your own way and just see if you get the same thing. Yes?
Alright, so can we go like back up with the 7? I'm gonna subtract the level.
10 minus 7 is 3, and I divide by 4 to get 3/4.
Okay.
Is that better? Everyone? Okay, so let's look at the other equation. This time we have negative 3/4 x. Negative 3/4 minus 1. But that's negative 4/4, right? Negative 3/4 minus 4/4 is negative 7/4. The same thing. The denominator is the same. So you have 3x equals 7. So x equals 7/3. I don't want you to change your style unless you think that mine is better. If it's not better, just use your own method. Stick with your own method if that's better for you.
I have a question.
Yes, please.
So, if they don't, so what if we get another equation with a fraction in it, and they don't, like, once we get the two equations,
Solutions
yeah, and they don't have the same denominator, do we have to find the least common denominator first?
of the solutions.
No, like see how
Here you don't have to use my method. You could have multiplied both sides by 4 to eliminate fractions. It doesn't matter. The method is not important. You can multiply both sides by 4, eliminate fractions, and then you'll get the same answer, no matter what. Is that better?
Yeah.
Okay. I would like us to work on a word problem with what we've been looking at. Okay, so here it is on page 187. I'm looking at exercises either 109 or 110. This is an application of what we've been doing. So let's take a look at these graphs right here. It says the graphs show the percentage of jobs in the U.S. labor force held by men and by women from 1970 through 2015. Exercises 109 and 110 are based on the data displayed by the graphs. So you like to look at men or you like to look at women as jobs between 1970 to 2015? Okay, we decided to pick women. So let's take a look. So let's write the formula. We are given a formula. So this is problem 110. We're given p equals negative 1.6 the square root of t plus 62. It models the percentage of jobs in the U.S. labor force P held by. Oh, I'm sorry, I chose 110. I thought that 110 was for men, for women. Let me write the other one. Okay, so let's. I'm sorry, I didn't mean that.
It's okay,
Sorry,
I'll
Elizabeth.
attach to
My apologies. Use the appropriate graph at the bottom of the previous column to estimate the percentage of jobs in the U.S. labor force held by men in 2010. So they want us to look at the graph and come up with an estimate of the. Let me also write the P is percentage, and T is the number of years since 1970. So what does that mean? T is what for 1970? 0. Very good. Okay, so it says use the appropriate graph to estimate. Give your estimation to the nearest percent. Okay, so here it is. And they want us to find it in 2010. What will you say for men roughly? Very difficult to read, of course.
51%.
51, 52, 53. I would agree with any of that. Okay, you want to say 51? Let's say 51. So in 2010, T equals how many years? T equals, very good, 40 years. Y, which is in this case P, is, you said 51%. Perfect. Part B. This is part A. Part B. I wanted to ask you, what type of expression is this? Is it polynomial? Is it quadratic in form? Is it... Very good. It's a radical function. Indeed, radical function. After the next section, we're going to start functions. So thank you for identifying it correctly. Very good. Part B. Use the mathematical model to determine the percentage of jobs in the U.S. labor force held by men in 2010, around to the nearest 1/10 of a percent. So what will you say? We're asked to use the equation to determine the same thing that we determined with the graph. What am I plugging in?
40, 13.
So what am I plugging in?
P
Yes, P equals
negative 1.6.
-1.6.
Square root of 40.
Indeed,
Plus 62.
plus 62. Excellent. So we only knew, so we read from the graph the percentage. So we only have the time, which is the number of years. So let's now go to the graphing calculator.
Okay, I have a question.
Sure.
Why didn't we put the 51% into P if we already had P?
Because we estimated.
That's what we're asked to use the model now to determine the same thing.
Okay.
We cannot trust that. Actually, that is the exact number, right? What they plotted. The model was determined based on the points that they came up with, and the model cannot be perfect. Okay, so we have negative 1.6, the square root of 40, you know me, I have to have parentheses, outside plus 62. And enter. So I got 51.88. So approximately 51.9%. Good reading. Okay? Although it's difficult to read from the graph. According to the formula, when will, that's part C now. According to the formula, when will 49% of the jobs in the U.S. labor force be held by men? What type of question is this? What are we given? What are we asked to do? So now we are given 49%. What is given now? Is it X or T? I'm sorry. Is it T or is it P? Of course. So now, can anyone dictate a new equation that we have to solve?
49
Exactly. Equals?
Negative 1.6 square root of 40
The square root of x.
Good. Plus?
plus 62.
Good. What type of equation is this and how do I solve it?
Right.
Yes. Awesome. Well done. It's a radical equation. You understand how important it is to identify the equation correctly? Because once we identify it correctly, you see all these equations have a particular method. Linear is one thing, quadratic is a different thing, polynomial a different thing, radical is a different thing, rational a different thing. What else we know? Absolute value different, all different, right? So good. So what do we need to do? I would agree with 1.6 the square root of x. And then from 62 I subtract 49 and I get 13. Only because I prefer also the radical on my left. That's just a habit. You don't have to. And I also prefer to have no negatives. So I don't have to worry about multiplying both sides by negative 1. So then, yes, we can. Right here, there is really not a need. But yes, I would do this. I would square both sides. 1.6 squared times x equals 169. And then I would get this. Squared, of course. So with a graphing calculator, so we have 169 divided by 1.6 squared. 66. What does 66 mean?
That's the number I use.
Since, excellent, well done. So approximately 66 years since, excellent, great job, which is in the year 2036. Well done. So